So let's come back here and let's go back to the code. And in this scenario, what we're going to do is we're actually going to start pulling information from smart contracts. We're going to do it on behalf of the user that logged in. So that creates an opportunity for us to be able to create more personalized experiences based on the information that is captured on the blockchain. One of the things that's special about Credenza's experiences, we have the ability for multiple sources to be able to write into that blockchain on behalf of the user and then the user to gain the benefits of the information that's there. So in this scenario, we're just going to actually use a loyalty contract. Loyalty contracts, one of the more popular contracts that we've been asked for. Before we do anything else, I like to mention the fact that, hey, we only need 3 JavaScript libraries. Well, there's a 4th JavaScript library that I highly recommend if you're doing anything with smart contracts. It's also provided by Credenza. We call it contract lib. And again, of course, I'm going to copy and paste it because all you need is to copy and paste it. We also have it on unpackage and JS deliver, and it does have, and that's obviously in the contracts-lib. You can find it very easily. You can look at it in the node package manager as well, but you'll see some information about it. This is a utility that stores all the critical information about all the smart contracts that Credenza provides and actually embeds a lot of information, encapsulates a lot of critical information that is required for instantiating contracts, particularly around the application bytecode interface, the bytecode that's associated with it, and all those other things that are needed by the Ethers library and by the Passport library to actually make these things powerful. So once you have that contracts lib in place, that's going to make things a little bit more powerful for us. In the meantime, one of the other things we need to do is, well, we need to actually have a loyalty contract that's published. Fortunately, as you might guess, we actually already published a loyalty contract that we use for test purposes, and that's the one I'm going to use here. And once again, it's going to be a copy and paste. If you work with Credenza, we will most likely provide you with your own loyalty contract that is going to have this identifier that is similar to this. It's going to be a hex string of digits, usually numbers and letters, that represent the address of the loyalty contract. So in this situation, we have where the loyalty contract is. That's great. But now let's say you want to be able to check the points that you have in this loyalty contract. Now we still have everything as before, and as I promised, I'm going to get rid of that pesky alert. But in fact, let me do something different. Instead of checking and using the alert, let's do this, and let's check on points. So let's assume we're going to create a function. You know what, for now I'm going to be lazy. Let's use alerts again. I apologize, I lied. Let's use the alerts again, and with the alert this time, we're actually going to get our points. And let's call the function checkpoints. And we're just going to say, well, you know what, checkpoints, and then just a couple of parens there, I believe. And so now that's the function that we need to create. So we're going to call that, but we're actually going to create it outside here. So let's create constant checkpoints. So I just realized that it should be plural. You probably don't just have one point. Equals an async function again, because we are going to have to wait a little bit for the blockchain to correspond before we get any more information. So I'm going to back this up over here. That's enough. And the first thing we need to do is we need to be able to take the identity of the user and apply it to the blockchain. And that's going to require a little bit of blockchain coding understanding. It's not deep. If you just follow these steps, it should be straightforward enough to do. If you're interested in learning more, there is a deeper understanding around the concept of providers and signers. But to keep it relatively loose, you're just going to have to trust me a little bit on this one. But we are going to create a provider, or actually we're going to retrieve the provider, which of course Passport allows, and it's going to be get web3 provider. So now this is actually a, let's consider it a tunnel into the blockchain that Passport provides on behalf of the website. And it basically says we've got a tunnel into the website, but there's a second half of it that basically says, great, you have the tunnel, but who is it that's signing it? And everything about the blockchain is about the identity of the user that's making the call. There are there are no truly useful anonymous calls. There are some useful anonymous calls. I shouldn't say that, but in a lot of cases, the caller is very important because there is code access security that determines who's allowed to get certain information, or sometimes when the caller identifies themselves, the smart contract can receive the information that is specific to that caller. So it's great to be able to identify yourself, and you identify yourself by your assigning authority. And of course, Passport, and one of the great things that Passport does is that once you have the provider that's provided by Passport, then what you do is you access that provider and you get the signer. And this is all, again, behind the scenes, the little man behind the curtain at Passport that's taking care of a lot of this. But the minute you have that signer, now what you're able to do is you're able to create that smart contract, or I should say you're able to retrieve that smart contract. Now, as you'll notice in each case, we are doing awaits because there is a synchronous aspect and these things need to happen in sequence. We can't just gloss over it. But in this case, when you have a contract, we're going to do await. And in this case, because we created that the library include as a script include, we're going to have to access to the window, and then it's going to be credenza contracts. And then we're going to call a method called get credenza contract. So this is one of the foundational methods that's associated with the contract lib that I was mentioning earlier, this helper function. There are other ways to do this that are much more laborious for the purposes of this, and part of the reason we created this was to create a simpler way to do it. So once you have this, you're going to pass it basically some JSON, and the JSON is going to have the address of the contract, which, as you can remember earlier, we had loyalty address. You're going to pass a wallet. Now, this is when we're signing for ourselves. You also have the ability to pass the provider and not bother with the signer. But if you want to identify yourself, and in this case, we do want to identify ourselves, we want them to know that we're calling, we're going to pass in the signer, which we just created earlier, and then we need to identify the name of the contract, which in this case is called, surprise, surprise, loyalty contract. And yes, I will spell it properly. Very important to spell properly. So there is loyalty contract. Now what we've done here is great. We have a contract. The contract is a JavaScript programmable object, just like Passport is a JavaScript programmable object. And each smart contract comes with a series of methods and attributes that are retrievable and can allow for some useful information. In this scenario, what we have is that we have the ability where we want to get points, and there happens to be a method associated with the loyalty contract that says get points. So we're going to do await once again, and again, don't like always doing await, but in this case it's necessary. We're going to get that contract that we created, and then we're going to call out checkpoints. And checkpoints, and we call the user that we want to access. And just for the point of completeness, we're going to actually use Passport. We could just pass this without a parameter, and I think it might default to the signer, but just for completeness and just for hygiene on this, we're actually going to literally call, or we're going to embed the address. In this case, if you remember, it's Passport, and then it's the user, and then within the user, it's the address, which represents the Polygon address for the user. And now points has the user. So in this case, I'm actually going to do something different. Again, forgive me for I'm using alerts, but I'm just going to put the alerts up here instead of returning it. You'll still get the points. And it's probably a good idea to set this to await. And I just noticed that I mistyped that. So now we've got loyalty address up here. So we're going to click save and close. We're going to click save up here. And then when we do a preview over here, we hit refresh. And when we hit refresh, what you're going to see is 12 pop up. Not very exciting. This user did happen to have 12 points with this. But what you're going to see in the next lesson is how we're able to modify it on the server side and how it will affect on the blockchain side. So that is the end of lesson 2.